Mixing up SQS and SNS is the kind of slip that costs you a point in a cloud scenario question, and in production, it can cost a lost order when a service hiccups. Welcome to Hired in IT. Today, we're comparing Amazon's Simple Queue service and Amazon's Simple Notification service because these two show up all over cloud learning paths and entry-level architecture work. Our mission is to make you useful, not just conversational. By the end of this video, you'll be able to decide whether a scenario needs a queue, a pub subtopic, or both, and explain the difference in one confident sentence. Let's get into it. A customer clicks buy. The payment service is temporarily unavailable, and the request still does not disappear. Instead of making the order service wait for payment processing to finish immediately, the application can place work onto a queue, so another component can process it when the downstream service is ready. That decoupling improves resilience because one temporary outage does not have to take down the entire workflow. But there is an important production lesson. Payment operations must be designed to handle retries safely. If the same message is processed twice, the customer must not be charged twice. That is why messaging architecture is not just about moving data. It is also about reliability, retry behavior, and idempotency. For Cloud Practitioner, the first decision is simpler. When work needs to wait safely for a consumer, think Amazon SQS. By the end of this video, you'll be able to do three things cold. 1. Read a Cloud Practitioner scenario and decide whether it needs SQS, SNS, or both. 2. Explain how SQS handles message delivery and retention, and tell standard queues from FIFO queues. 3. Explain how SNS distributes messages to multiple subscribers through topics, what fanout means, and the kinds of endpoints it can reach, like email, SMS, Lambda, and SQS queues. Synchronous communication means service A calls service B and waits for a response before it can continue. Imagine an order service calling an inventory service. If inventory slows down, the order service may sit waiting until the request times out. Now, one slow dependency is affecting another service and possibly the user. When the work does not require an immediate synchronous response, a queue can break that dependency. Instead of waiting for inventory to finish right now, the order service places a message on a queue and continues. Inventory processes the message when it has capacity. The important phrase is when the workflow can be asynchronous. Not every synchronous API call should become a queue. If the user genuinely needs an immediate answer, synchronous communication may still be appropriate. Queues are most valuable when you need to decouple services, absorb spikes, survive temporary consumer outages, or process work later. A queue breaks that direct link. In a queue-based design, a producer sends a message to a queue and moves on. The consumer retrieves the message when it's ready and removes it after processing. The message itself waits in the queue. If the consumer is slow, briefly down, or overloaded, the producer never depends on the consumer being available. That decoupling is the entire point. Let's see the SQS lifecycle from the command line. First, create a standard queue. AWS SQS create queue, queue name orders. AWS returns the queue URL. You will use that URL in the next commands. Now send a message. AWS SQS send message. Queue URL your queue URL. Message body order 133. Next, receive a message using long polling. AWS SQS receive message. Queue URL your queue URL. Wait time seconds. 20. Notice wait time seconds. Instead of immediately returning an empty response when no message is available, SQS can wait for a message to arrive. That reduces unnecessary empty polling. The response includes a receipt handle. After your application successfully processes the message, delete it using that receipt handle. AWS SQS delete message, queue URL, your queue URL, receipt handle, your receipt handle. That last step matters. Receiving a message does not permanently remove it. The consumer processes the message and then explicitly deletes it. That is the basic SQS loop: send, receive, process, delete. Always verify the current AWS CLI syntax before using commands in production. SQS has two timing concepts that beginners often mix up. The first is message retention. Retention controls how long an unprocessed message can remain in the queue before SQS removes it automatically. The exact configurable minimum, maximum, and default should always be verified in the current AWS documentation. The second concept is the visibility timeout. When a consumer receives a message, SQS temporarily hides that message from other consumers so the first worker has time to process it. But receiving the message does not delete it. If the worker finishes successfully, it should delete the message. If the worker crashes or never deletes it, the visibility timeout eventually expires and the message can become visible again for another processing attempt. That is why SQS consumers must be designed for retries. Retention answers: how long can this message stay in the queue? Visibility timeout answers: how long should this message stay hidden while a worker is processing it? Those are two different controls. Let's make sure the retention and visibility concepts actually stuck. A consumer receives a message, then crashes before deleting it. What happens next? SQS has two queue types, and the exam will give you a scenario and expect you to match the requirement to the right one. Standard queues are designed for very high throughput, best effort ordering, and at least once delivery. That means messages can occasionally arrive out of order or be delivered more than once. FIFO queues are for workflows where the order of related messages matters, and duplicate sends are a concern. FIFO is commonly described as preserving message order and offering deduplication, which reduces the risk of a producer retry creating duplicate messages. So if a question says, "Keep the updates for this order or this customer in sequence," FIFO is the better fit. If it says, "Process as much work as possible and make the consumer safe to retry," standard is usually the answer. One important reality check: FIFO does not make a downstream payment, database update, or email magically happen exactly once. Your consumer should still be designed so that retrying a message cannot repeat a business action. Here is the duplicate trap in practice. A customer places one order. With a standard queues at least once delivery model, the same message can occasionally be delivered more than once. If the order service charges the card every time it sees that message, the customer could be charged twice. The safeguard is idempotency. Give the order a unique ID, record that it has already been handled, and make a repeat message safe to ignore. FIFO queues help when you also need ordered, deduplicated messages. For example, order status updates that must stay in sequence. But even with FIFO, a worker can finish a business action and then fail before it deletes the message. That is why idempotent consumers are a best practice for every important workflow. A dead letter queue is the parking lot for messages that repeatedly fail processing. You attach a DL queue to your main SQS queue and configure a maximum receive count. If a consumer keeps receiving a message but can't process it successfully, That message can eventually be moved to the DL queue instead of continuing to consume retries and processing capacity in the main workload. The rest of the workload can continue processing, while your team inspects the failed message separately to figure out what went wrong. Maybe the message contains bad data, maybe a downstream system rejected it, or maybe your application has a bug. The key idea is simple. Don't let repeatedly failing messages disappear or keep retrying forever. Isolate them, investigate them, fix the problem, and then decide whether they should be processed again. Before you leave SQS, let's lock in the typical use case patterns. Decoupling microservices, so one service can finish without waiting for another. Buffering requests, so a web server can drop work into a queue instead of overloading workers. Asynchronous processing, like resizing images in the background. And independent scaling, where you add more consumers to drain a backlog without changing your front end. When an exam scenario describes one of these patterns, SQS is very often the answer. Quick checkpoint. Which SQS queue type should you choose when message ordering and duplicate send prevention matter? If you said FIFO, you're on solid ground. FIFO is the queue style commonly associated with ordered, deduplicated workflows. Standard is commonly associated with very high throughput and best effort ordering. But remember the production lesson. No queue fully removes the need for a consumer that can safely handle retries. Make your processing idempotent so a retry doesn't repeat something important like charging a customer twice. A warehouse app logs a shipment. Within seconds, inventory gets the count, billing prepares an invoice, the customer gets an email, and a Slack-style channel posts a notification. 4 completely different systems, but the app sent only one message. How does one message become 4 copies without the sender knowing any of the recipients? That's the exact problem Amazon SNS solves. In SNS, a publisher sends to a topic, and every subscriber attached to that topic receives its own copy. That's PubSub. Here is the fanout pattern. A publisher sends one message to an SNS topic. The publisher does not need to know every downstream system individually. The topic contains the subscriptions and handles distribution. One subscription might send the event to a Lambda function. Another might deliver it to an SQS queue. Another might send an email notification. SNS then attempts delivery to each subscribed endpoint according to the delivery behavior supported by that endpoint and topic configuration. That distinction matters. Do not think of SNS as guaranteeing exactly one perfect copy to every destination under every failure condition. Think of it as a publish and subscribe service that separates the publisher from the subscribers and handles one-to-many message distribution. The publisher publishes once. The topic handles the subscriber fanout. SNS follows a publish-char-subscribe model. When a message is published to a topic, it is distributed to subscribers without them polling for it. In training materials, SNS is commonly described as handling 2 messaging jobs. One is app-to-app, where your services talk to each other, a payment microservice notifying an order microservice. The other is app-to-person, where a service reaches a human through channels like email, SMS, or mobile push. SNS is generally associated with notifications and fan-out scenarios. If you need strict ordering or complex multi-party guarantees, check current AWS documentation for the right configuration. Here are 6 common endpoints an SNS topic can push to, a Lambda function for code execution, an SQS queue for durable background work, an HTTP or HTTPS endpoint for a webhook, an email address, an SMS number, or a mobile push notification. When you see a prompt that says, "Store the same event for later processing," the answer is often an SQS queue, not an email notification, and not a direct Lambda invocation. Keep that distinction visible while these options are on screen. Let's talk about SNS topic types as patterns, not memorized rules. SNS topics are commonly grouped into two families, standard and FIFO. Standard topics are the usual starting point for broad fanout to many different endpoint types. FIFO topics are meant for narrower workflows where strict ordering and duplicate prevention are the central requirements, and their delivery options may be more limited, so check current AWS documentation before you assume an endpoint is supported. The exam pattern is simpler. Choose standard for broad notification fanout. Choose FIFO only when the scenario explicitly needs strict ordering and deduplication, then verify the current topic, queue, and subscription configuration before you build. Use the requirement first, the topic type second. Checkpoint before the head-to-head. Which messaging service is commonly associated with delivering one publish message to many subscribers at once, where subscribers do not request each message? The answer, in general terms, SNS. It is commonly described as pushing a message to everyone subscribed to a topic. SQS is more commonly described as a queue that consumers request messages from. Delivery details can vary, so always confirm current AWS documentation. Here's one of the easiest ways to separate SQS from SNS. SQS is designed to hold work until a consumer is ready to process it. Messages can remain in the queue for a configurable retention period from 1 minute up to 14 days. SNS solves a different problem. It's designed for immediate message distribution to subscribers. So when an exam scenario says, "Hold this work until a worker is ready," buffer requests during a traffic spike, or process this later, think SQS. When it says, "Send this event to multiple subscribers," think SNS. The shortcut is simple. SQS stores work for consumers, and SNS distributes events to subscribers. Let's put SQS and SNS side by side. SQS is a queue. One or more consumers can pull the same queue, and those consumers effectively compete for the work waiting inside it. A particular message is normally processed by one consumer at a time, although retries and repeated delivery are possible depending on queue type and failure conditions. That pattern is often called competing consumers. SNS solves a different problem. SNS uses publish and subscribe. A publisher sends one message to a topic, and the topic distributes that message to its subscribed endpoints. So the easiest mental model is SQS distributes work across workers. SNS distributes an event across subscribers. SQS is excellent when work must wait safely until a consumer is ready. SNS is excellent when one event needs to reach multiple destinations. And when multiple destinations each need their own durable backlog, combine them. SNS fans the event out, and separate SQS queues buffer the work for each consumer. Here is the architecture that handles a busy checkout spike. An order event is published to an SNS topic. The topic immediately fans a copy of that event out to 3 separate SQS queues, one for inventory, one for billing, and one for audit. Behind each queue, a different backend worker pulls messages at its own pace, so a slow billing system does not block inventory from moving. SNS does the instant one-to-many distribution. SQS gives each downstream team its own durable, rate-controlled backlog. And because each queue is independent, every team can scale, retry, and monitor its workload separately. Here's an architecture trap worth remembering. SNS can retry failed deliveries, and the exact retry behavior depends on the endpoint and delivery policy. But SNS is still not a worker-controlled backlog where an application simply processes messages whenever it catches up. If a downstream service might become slow, overloaded, or temporarily unavailable, a common pattern is to put an SQS queue between SNS and that service. SNS publishes the event to the queue, and SQS holds that service's copy until its workers are ready to process it. If billing slows down, its queue can build a backlog without forcing inventory or another subscriber to slow down with it. That's why these services work so well together. SNS answers, "Who needs this event?" SQS answers, "When is this worker ready to process it?" SNS distributes. SQS buffers and decouples. Now let's place SQS, SNS, and EventBridge next to each other. SQS is primarily about queuing work. It gives consumers a durable backlog they can process at their own pace. SNS is primarily about publish and subscribe fanout. A publisher sends to a topic, and SNS distributes the message to supported subscribers. SNS can also filter subscriptions, so not every subscriber necessarily has to receive every message. EventBridge is closer to an event routing platform. Events arrive on an event bus, and rules examine those events and route matching events to supported targets. EventBridge is especially useful when you are integrating many AWS services, SaaS applications, or event-driven components and want routing based on event content. So do not reduce the difference to SNS sends everything, EventBridge filters. SNS also supports filtering. The better distinction is SQS is for durable queued work. SNS is for topic-based PubSub and fanout. EventBridge is for event bus routing and integration across event producers and targets. For Cloud Practitioner, focus on recognizing the architecture pattern rather than memorizing every feature. Quick checkpoint before we move to hands-on work. A billing service occasionally falls behind. You already fan out order events with SNS. What do you add so billing can catch up without slowing inventory or audit? The answer: add an SQS queue between the SNS topic and the billing worker. That gives billing its own durable rate-controlled backlog, so one slow team does not block the others. Let's walk through a typical console flow for creating an SQS queue and reading a message. After searching for SQS, click Create Queue. Name it Orders and keep the type as standard. That's the default choice for most workloads. Create the queue, then open Send and receive messages. Send a test message with the body order 123. Now here's the key observation. In many console workflows, you initiate a receive or poll action to read queued messages rather than having them appear automatically. The exact console behavior can change, so check current AWS documentation. That manual request step is the common mental model for SQS's pull style pattern. Now let's publish an SNS message to an email subscriber. Open SNS. Create a topic called Order Events. Then create a subscription using the email protocol and enter your address. SNS may require a confirmation step by email before the subscription becomes active. The exact workflow can vary, so check current AWS documentation. Once confirmed, go back and publish a test message. That single publish action is designed to fan out to every confirmed subscriber on the topic. That's one-to-many delivery in real life. Now let's perform the basic SNS workflow from the AWS CLI. First, create a topic. AWS SNS create topic. Name order. Events, AWS returns the topic ARN. Next, subscribe and email address. AWS SNS subscribe. Topic ARN your topic ARN. Protocol email. Notification endpoint uexample.com. AWS sends a confirmation message to that address. The subscription will not receive normal topic messages until the recipient confirms it. Once confirmed, publish a message. AWS SNS publish. Topic ARN your topic ARN. Message. Order 123 was created. That is the key operation. The publisher sends one message to the topic. SNS then handles delivery to the confirmed subscriptions associated with that topic. If the topic also had an SQS subscription, a Lambda subscription, or another supported endpoint, the same publish could be distributed to those destinations too. No application side loop through every subscriber is required. Always check the current AWS CLI documentation for exact options before using these commands in production. On cloud certification exams, SQS and SNS usually appear inside scenarios rather than simple definition questions. Your job is to identify the requirement hiding inside the story. If the workload needs to decouple two services, buffer requests, survive temporary consumer outages, or process work asynchronously, SQS is usually the stronger answer. If one event needs to notify or fan out to multiple subscribers, think SNS. And if one event must reach multiple independent systems, but each system needs its own durable backlog and processing speed, think SNS plus separate SQS queues. Keywords like decouple, buffer, notify, and fanout are useful clues, but don't choose an answer based on one keyword alone. Ask what the architecture actually needs. Durable work, SQS, one-to-many distribution, SNS, fanout plus durable independent processing, SNS plus SQS. That's the decision pattern you want to take into the exam. Quick hands-on recall. In many console workflows, reading a message required an explicit receive or poll action. What does that illustrate? It highlights the common mental model for SQS. Consumers ask the queue for messages rather than having them delivered automatically. SNS, by contrast, is commonly described as pushing to subscribers. Delivery behavior can vary, so confirm current AWS documentation. Screenshot this screen for the cheat sheet. SQS is pull-based. Consumers pull it for work, and the queue can hold messages for a configurable retention window. Check the current AWS docs before you rely on a number. Design consumers to be safe to retry whenever delivery can repeat. One SQS queue type is built for high throughput with best effort ordering, while the other preserves order within message groups and supports deduplication. SNS is push-based, PubSub. One published message can fan out to multiple subscribers. A standard topic can fan out to a range of supported endpoint types, so verify the current targets in the AWS docs. FIFO topics serve supported order-sensitive delivery patterns, not every endpoint type. When one event must reach multiple teams and each team needs its own durable backlog, use SNS plus SQS queues. Here is the pattern to draw from memory. A file event publishes once to an SNS topic. The topic fans copies out to 3 separate SQS queues: inventory, billing, and audit. SNS handles the one-to-many broadcast immediately, while each SQS queue holds its copy so that team can process at its own pace, retry safely, and not lose the event. If an exam question says one event and multiple teams, The answer is SNS plus SQS. Here is the architecture to remember. An order event is published once to an SNS topic. SNS fans that event out to 3 different SQS queues, one for inventory, one for billing, and one for audit. Each queue now holds that team's copy independently. Inventory workers can process immediately. Billing can fall behind temporarily. Audit might process much more slowly. None of those processing speeds have to match, and each queue retains its messages according to its configured retention, retry, visibility, and dead letter behavior until processing succeeds or those policies take effect. That last point matters. Do not think of this architecture as meaning a message can never be lost under any possible configuration. Think of it as giving every downstream system its own durable buffer and retry boundary. SNS handles one-to-many distribution. SQS handles durable independent processing. Together, they create a resilient fanout architecture. Next up is Amazon EventBridge. You already know 2 messaging patterns. SQS is built around durable queued work. SNS is built around topic-based publish and subscribe fanout. EventBridge adds another important pattern, routing events through an event bus based on rules. A producer can emit an event such as order created payment failed or instance state changed. EventBridge evaluates that event against configured rules and sends matching events to the appropriate targets. SNS can also filter subscriptions, so the difference is not simply that SNS broadcasts while EventBridge filters. Think of SNS primarily as PubSub messaging and notification fanout. Think of EventBridge as event bus routing and integration, especially when you have many event producers, AWS services, SaaS systems, or downstream targets. In the next video, we'll put SQS, SNS, and EventBridge into the same architecture so you can see exactly when each one belongs. Make this real before the next video. First, open your AWS billing page and confirm what is currently covered in your account and region, so the rest doesn't produce surprise charges. Create an SQS queue, send one message, and receive it using the same console flow from earlier. Next, create an SNS topic, subscribe your email, confirm the subscription in your inbox, and publish a message. That shows a published message reaching a subscriber without waiting for a poll. Finally, write 2 one-line scenarios. The first, process each order in the background and make a retry safe. The second, notify multiple teams when a shipment is logged while letting each team process the event at its own pace. For each scenario, decide whether you need SQS, SNS, or SNS plus SQS, and explain why in one sentence. Here's your final checkpoint, and this one is useful beyond the certification exam. An interviewer asks, "What's the difference between Amazon SQS and Amazon SNS?" Here's your 2-sentence answer. Amazon SQS is a durable message queue used to decouple producers and consumers so workers can process messages asynchronously at their own pace. Amazon SNS is a publish and subscribe service used to deliver one message to multiple subscribers, and you can combine SNS with SQS when each subscriber needs its own durable queue. If you can explain that without memorizing it word for word, you understand the architecture. And if the interviewer asks when you would use both, give them the checkout example. Publish one order event to SNS, fan it out to separate SQS queues for inventory, billing, and audit, and let each team process its own queue independently. That's no longer just an exam answer, That's an architecture answer. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.